Okay, hello everyone. Welcome to attend today's training. This is the last training about for uh, this round training program, and today's topic is about the ECAM functions. I will introduce how to use ECAM function with the frying sewing applications, and this is the catalog for today's trainings. I will show you some flying sewing applications and introduce how to generate a ECAM flying sewing curve. And then I will show you the sewing flying sewing demonstrations. For the flying sewing applications, uh, we can see these pictures. It shows the movement between the master axis and the slave axis. We can saw the difference between the flying sewing and the rotary sewing. For the rotary sewing, the slave axis always run in the same directions, but for the flying sewings, we can see he changed the directions while he's moving. The slave axis uh, accelerate to catch up with the master axis and run together in the same speed. And during this speed is the same we called sync zone. And during this sync zone, he made some cuts or some uh, act, other actions. And then he will return to the origin point. This is the speed and the position relationship between the master axis and the slave axis. The flying sewing control can be used in a pipe cutting machine or beverage fillings and other equipment, so that they need to move with the processed products. And this actions is a slave axis start to accelerate and follow the processed products. And after he leaving the sync zone, this area, and he will decelerations, and then he will stop. Once he stop, and then he will go back to move back to the origin points positions. So it's the key positions is in the range of the sync zone. In this sync zone, the speed is the same, so we can make some actions we need, such as cut or feeding. And for generate the flying sewing curve, we also use ecan tbx instructions. So it's the same use to the generate the rotary cut. Sorry, here. And they also have four parameters. The first is to uh, identify the first address of the ecan table parameters, something like the length of master axis and the length of slave axis. And for the second parameters, we identified the curve type. For example, rotary curve, we set the second parameter as 100, but now it's a flying cut curve, so we set these parameters as 101. And for the third parameters, it's about the data buffer to store the ECAN table. which generated by these instructions. And the last parameters is about the result of the table generations. If its value is less than zero, it means we doesn't generate the ECAM curve successfully. And if the value is bigger than zero, the value means how many segments it generates. It's based on the resolution we set. As you can see here, for the second parameters, the number of table segments were stored in the 39 registers. For example, if we set it as D 100, so the segments number were saved in D 138. And this is for the error code, which will, if we don't generate the curve successfully, this value will be displayed in the last parameters. So that we can check this table and make some adjustment for our gener parameters adjust. Okay, any other about this part? Because this part is almost the same for the lottery card, which I introduced last week. The only difference is the second parameters. We need to set it as 101 to generate a flying saw curve. Okay, and then we can uh, see some the parameters we set for the first register, the S0 here. The first to adjust is to set the master SX length. And the third and the fourth parameters registers, we use it to set the length of slave axis. Both the length is 22-bit integer. And then the the fifth and the seventh and the sixth address, we set it as the length of the sync zone, which suggests to set the 1/3 of the slave length. If we set the sync zone occupied too many parts of the slave length, it might need the fast acceleration and the slave acceleration, deceleration of the slave movement, and even will cause the uh, fail to generate the ECAM curve. And for the 7 and 8 adjust registers is to set the synchronization magnification, because sometimes the speed of the master ASICs and the slave ASICs is not the same. For example, we use 300 parts of for the master ASIC to run uh 10 millisecond micro centimeters, 10 centimeters, and for the sorry, sorry, and for the about we need about 100 paths to make the slave ASICs run 1 centimeters. So we can calculate is about 1/3 is the slave axis synchronization magnifications. This parameter measure the in the sync zone, the slave and the master ASIC is in move in the same speed. And for the parameter 5, is for the maximum magnification limit. It's not very necessary parameters. We set this parameter larger than the sync zone magnification is okay. And then for the parameters 10, it's about the acceleration curve. If we set it as 0, it's a constant acceleration curve. And if we set it as 1, it's a constant jack curve. It's you can set it based on your requirements. And for the adjust 11 is to set the can curve. It's to set the different position of the sync zone. It's not recommended to adjust these parameters. It's more recommended to adjust the origin position of the slave axis. It's more accuracy. Okay, and for the adjust 12, it's about the resolution. It has the range is for the flying saw is from 62 to 511. The, the larger resolution you set, the ECAM curve generated will occupy more registers. And for the parameters 8 and 9, it's set the sync zone where the sync zone start point and the end point position of the sync zone. Because after the ECAM curve generated, we can get a maximum range of the sync zone, but sometimes we don't need all this range. We can choose which part we need to operate. And for the parameters 11, it's for the maximum magnification for the actual operations slave axis. It's also not necessary parameters. And then we can watch this video about how the ECAM curve runs. It's still recommended to clean the PLC memory before we run the ECAM project in our PLC. And this PLC program divided by three parts: prepare and generate curve and the ECAM curve running. For prepare, we just set some parameters about the master unique path length or slave maximum magnifications. Some parameters we can uh, set the register value and enable the high speed counter because in this program I use Y terminals to send the pulse to the high speed registers and also uh, reset the some relative special registers. And for the second part to generate the ECAM curve, as we can see, I set the master length as 5,000 and the slave length as 2,000. For the sync zone length, I set it as 600. And then is the floating calculations to get the sync zone multiplication. It's about 0.5. Yeah, sorry. I think we can see this video. Yes, it's not very clear, but it's 0.5 because for the same length, travel master SX needs 2,000 paths, which is I set, and for the slave, it just needs 1,000 paths to travel the same distance. And then, as you can see, the ecan_tbx instruction has been triggered, and we can see the results value is 101. It means we generate the ecan curve successfully. And for this four parts is to set the sync zone signal and the start and the end position of the sync zone. So here I set because the ECAM curve stoned by the first address is D1000. So D1004 is to set it as 1. It means to enable the sync zone signal. And we use the Y7 as the sync zone signal output. So I set D1008 as 7. And then we can set the start and the end position. As we can see, for this ecam curve generated, the maximum sync zone range is generated. So we just set the sync zone length range within this range. So I set it as 900 and 1600. And then we can generate, we can trigger the ecan, ecan instructions. And for here, I set the D100, 1005 as 2. So it means we 1002. So it means we execute the ecan execute a aperiodic ecan curve. So and I set 1003 as 32. It means we use the actual signal to execute the ecan. So as you can see now, the must as uh, the must SX is running, but the ecan doesn't run. The slave doesn't move. And for this this project, I connect Y3 to X6 as the additional signal to trigger. As you can see here, I set X6 as the trigger signal. So here I triggered Y3 and the X6 get the signal, the ecan curve running. The slave X6 will run from 0 to 2000, and in this time, the sync zone signal will be triggered, which we can use this signal to operate some procedure. And then the X6, the slave X6 will go back from 2000 to 0 and finished one curve, waiting for another trigger signal. Okay, do you have any questions about this part? Because then I will show you to execute the ecan curve run again. And just now we just use the trigger signal. And sometimes we want the ecan curve is triggered by the actual signal, but wait for a delayed for some certain numbers of paths. So that in that case, we can set D 1003 as 33 because it means we use the actual start signal and enable the delay start. For example, I triggered M7 here and set the numbers The 1015, it means the how many paths we delayed. For here, start delay path setting. For example, we want it delayed for 1000 paths. And for trigger M2 to generate a ECAM curve, and the trigger M0. And then, as we can see, the ECAM curve doesn't, slave S6 doesn't running. I triggered M7. For the first 100 pulse of the master S6, the slave S6 doesn't run. And then it will make a one ECAM curve, and it stopped for the stop position is 6,000 for master S6, and the zero position, original position for the slave S6. We can trigger it again. It's also the same. S6 move forward and then go back. And we can set the 1005 as 0 to stop the ECAM curve. So that we can not trigger this ECAM curve anymore. And if I set position 0, and we can also set the execution time. For example, 3 times. And then we triggered S2. Triggered. So now you can see just one run, and the second time, and the third time here. Okay, this is about how the aperiodic ECAM curve runs. Do you have any other questions? Later, I will show you the periodic ECAM curve. Okay, for the periodic ECAM curve, we just set the different value of the D1005. These parameters. We can set it as 1, a pure periodic ECAM curve. Once the ECAM instruction start, it runs constantly. And the other is to set it as 4. It's a periodic delay ECAM curve. So here I set it as 4. a delay periodic curve. And then the first things we connect the PLC to PC and clean the PLC memory. So here I also trigger M2 to generate another ECAM curve. So in this demo, I set the master length as 7,000 and for the master A6 and for the slave A6 is 2,000. Slave async zone length is 700. And here the slave A6 sync multiplier I set it as 1. And for the resolution, I set it as 3,300. So as you can see, it's 301 segments here. And we can also enable the sync zone length, sync zone signal. So here I use a Y12 to output the sync zone signal. And for the range, we can set it as 1,700 to 2,000. This this data is for the master, not the slave ASICs. And then we triggered. Sorry, I need to set triggered M7 for delay start and for how many paths we delayed. Still, for example, delayed 5,000, and then we can trigger M1. And because I set this as 33, means we also need the actual signal and delay start. So here I triggered M3, M6. Y3 will get the trigger signal to X6. As you can see now, the ECAM curve is running. Oh, sorry, it changed back to 1,000. And for this time, it's not just run the ECAM curve just one time. It will run constant until we set this register D1005 as 0. And then he will stop. Okay, now it stopped. If we want just continue, we can just set it as 4. Sorry, or 1. It will accurate directly. Okay, do you have any questions about the periodic ECAM run for the flying cut application? It's almost the same for the flying sewing and the rotary sewing. It's just to set one different parameters, uh, one different parameters here, and the ECAM curve will generate totally different. But to run this ECAM curve is totally use the same registers, the same configuration. Okay, if you have any other questions, you can leave your message in our WeChat or WhatsApp group. And this is the last training about this round training program. For tomorrow, I will release the final exam test link in the group. So this exam time is from this Wednesday to next Wednesdays. It's about 7 days. So you can finish. Please arrange your time to finish the final exam. And for some trainers, doesn't submit the after class exercise. You can still submit until next Wednesday. For today's class, we also have the after class exercise. So please submit in time. If you fail to submit the after class exercise for more than 2 times, it's not allowed to pass the final exam. So please be sure it. Okay. Thank you for your attend. Uh, today's training is finished. Uh, Good luck for you all to pass the final exam. See you.